The universe is much larger than you realize. Something magical happened in 1609. It was a beautiful night with a clear sky. Hello and welcome to Z. Don't forget to subscribe and click the bell icon. The stars shone and sparkled as they had always done, but something was about to change. Galileo Galilei had heard that some Dutch spectacle makers had created an unusual optical instrument, a tube with two lenses at each end, through which distant objects appeared closer. Galileo dedicated himself to perfecting the instrument as soon as he knew the construction details, managing to increase its magnification power in a matter of months. However, it wasn't until the autumn of 1609 that Galileo did something truly extraordinary. Driven by scientific curiosity, he pointed his perfected instrument at the sky. The known stars revealed unexpected features, and new stars were added to the old Ptolemaic cosmos. Galileo recognized the inestimable value of his telescopic discoveries and how they provided new observational bases to support the Copernican theory of Earth motion. One of the first things Galileo noticed was that he counted an enormous number of stars, far more than he expected, far more than a human could conceive. This powerful tool essentially unlocked an updated version of our universe, providing us with a new perspective and ultimately changing our vision and understanding forever. Today, we are accustomed to telescope images and are aware that the universe is vast, but at the time, it represented a significant discovery. The stars that we could see with a small telescope outnumbered those visible with the naked eye. Scientists later discovered that the universe is ultimately made of agglomerates of stars known as galaxies, and that we live in one of them, the Milky Way. And as Galileo discovered that the universe was much larger than he had imagined, they discovered that it was much larger than they had imagined. But just how big is it? As an example, let us begin with the moon. The moon appears large in the sky for two reasons. It is either a close object or a large object far, far away. Astronomers discovered that we are in the first case while studying the kinematic and tidal effects of the moon and sun on the Earth. The moon is a close object, about 14 times the size of the Earth. They calculated that the moon must be 250.000 miles or 400.000 kilometers away from Earth based on its size. When we see drawings of the Earth and the moon, they often appear to be very close together. But don't be deceived. However, when we look at things in scale, this is how the Moon-Earth system appears. The moon appears close because we can see it so clearly without a telescope, but keep in mind that it is much farther away than most people realize. Of course, we can also try to figure out how far away the planets in our solar system are. Taking Kepler's laws into account, this is quickly accomplished. The third one, in particular, establishes the scale of our solar system, and we discover that the distance between Mars and Earth is approximately 33.9 million miles or 54.6 million kilometers. This is a vast distance. Our minds have been duped, and we have no idea how to visualize such a vast distance because we have no terms of comparison. Then, in 1920, astronomers Shapley and Curtis gave a talk at the National Academy of Science in Washington about how the universe was, according to them, based on scientific evidence. According to Shapley, the universe was essentially our galaxy, with nothing beyond the Milky Way. All of the stars we could see, as well as the planets and nebulae we could see through our telescopes, had to be part of the Milky Way. Curtis, on the other hand, believed that the Milky Way was just one of many galaxies out there. This had huge implications because it set the universe's scale to be enormous. Curtis was correct today, but at the time, things were murky, and it was difficult to tell who was correct or incorrect. The problem is that measuring distances in the universe is one of the most difficult things to do. Astronomers employ some well-known methods based on the distance ladder. They use various methods and tracers to determine the distance between the universe and us. The Cepheids, or variable stars, are one of these tracers. These variable stars are extremely bright, and their luminosity curve is unusual. As a result, they are used as standard candles in the universe to measure long distances. Shapley had obtained a really accurate measurement for the size of the Milky Way using the Cepheids, similar to modern measurements, and he also understood that the Sun occupied a peripheral position in the galaxy. So Shapley was very intelligent, and he was correct about a lot of things. Curtis, on the other hand, noticed that with the most powerful telescopes of the time, one could see some blurry spots, which they called spiral nebulae. Astronomers couldn't figure out what these objects were. Some thought they were balls of gas and dust in our galaxy, but Curtis thought they were galaxies. Galaxies similar to the one we were in. And he was quite certain of it. The only problem was that if they were galaxies with thousands and thousands of stars, they had to be very far away. Edwin Hubble discovered a Cepheid close to one of these nebulae, and the measured distance for this Cepheid, and thus for the nebula, was around 700.000 light-years away. According to Hubble, M31 was a galaxy located outside the Milky Way. M31 is now known as the Andromeda Galaxy, and we know that it is only one of our local group's galaxies. Andromeda is currently colliding with our Milky Way, and the two galaxies will merge in billions of years. The Antennae galaxies are one example of a galaxy merger. As you can see, the two separated galaxies merged quite clearly, and we can now appreciate how they form a system that resembles two antennae in shape. So the universe was much larger than we thought, as Hubble recently demonstrated. However, Hubble discovered that the universe was expanding. This expanded the universe even further. Hubble discovered something remarkable. The universe's galaxies appeared to be moving away from our planet. Furthermore, the faster a galaxy receded, the farther it was. This observation, made by Hubble in 1929, became the foundation for Hubble's law, which states that there is a relationship between the distance an object in the universe is from us and the rate at which it recedes. Measurements from multiple telescopes in January 2018 revealed that the rate of expansion of the universe varies depending on where you look. The nearby universe, as measured by the Hubble Space Telescope and Gaia Space Telescope, expands at a rate of 45.6 miles per second, 73.5 kilometers per second, per megaparsec, while the more distant background universe, as measured by the Planck Telescope, expands at a rate of 41.6 miles per second, 67 kilometers per second, per megaparsec. A megaparsec is 1 million parsecs, or approximately 3.3 million light-years, so this is almost unfathomably fast. Essentially, the further you travel, the faster objects move away from you, and the universe continues to expand, becoming larger and larger. But how big is it really? Hey! If you're still watching the video, it means you're incredibly curious about how big our universe really is. We are constantly striving to create videos that will pique your interest, so subscribe now and turn on the bell notification. So, in order to comprehend the size of the universe, we must perform some calculations. First and foremost, we must consider Einstein's general theory of relativity. However, we also require a good theory for the origin of the universe. Fortunately, we have the Big Bang Theory. According to the Big Bang Theory, we should be able to detect the cosmic microwave background, the oldest radiation in the universe. It contains a wealth of valuable information that is critical to comprehending the age of our universe. The European Space Agency's Planck space mission published the most accurate and detailed map of the universe's oldest light in 2013. According to the map, the universe is 13.8 billion years old. Planck determined the age by investigating the cosmic microwave background. The cosmic microwave background light is a traveler from far away and long ago, said Charles Lawrence, NASA's Jet Propulsion Laboratory's project scientist for the mission in Pasadena, California. When it arrives, it will tell us the entire history of our universe. Because of the relationship between distance and the speed of light, scientists can now look at a region of space 13.8 billion light-years away, right after the Big Bang. Astronomers on Earth, like a ship in an empty ocean, can turn their telescopes to peer 13.8 billion light-years in every direction, putting Earth inside an observable sphere with a radius of 13.8 billion light-years. The word observable is crucial. The sphere restricts what scientists can see, but not what exists. The sphere appears to be nearly 28 billion light-years in diameter, but it is much larger because the universe is expanding. As a result, while scientists may see a spot 13.8 billion light-years away from Earth at the time of the Big Bang, the universe has continued to expand over its lifetime. If inflation happened at a constant rate throughout the universe's history, that same spot would be 46 billion light-years away, making the diameter of the observable universe a sphere around 92 billion light-years. What lies beyond the observable universe, however, may be even more intriguing. The observable universe is all we can see right now, and it's possible that the rest of the universe is much larger than we think. Perhaps there are parts of the universe so far away that light from those places will never reach us because those parts of space are moving away from us faster than light. Essentially, we will always be blind to some aspects of our universe. To put it another way, if the observable universe was the size of your fist, the entire universe would be larger than the dwarf planet Pluto. As Stephen Hawking put it, the human race is nothing more than a chemical scum on a medium-sized planet orbiting a very average star in the outskirts of one of 100 billion galaxies. We are so insignificant that I find it difficult to believe the entire universe exists for our benefit. That's equivalent to saying you'd vanish if I closed my eyes. This is all for now. Thank you for being with us.